Hi guys, welcome to today's video on the area of regular polygons. Before we get started calculating the area, let's first review a couple terms that are going to be helpful today. The first is a regular polygon. So if you remember from last semester, we said a regular polygon is a shape that's got congruent sides as well as congruent angles. The other thing I want to look at before we get started is this concept of having a shape inscribed in a circle. And the reason I'm going to do that is because you're going to notice that a regular polygon has a lot of the same characteristics that we can pull from the things that we have in a circle. So what I've drawn here is a regular pentagon inside of a circle. And if you ever say that a shape is inscribed in a circle, please remember that that means every corner touches the edge of the circle. And what you should notice when I've drawn this in is that both the circle and the pentagon have the same center, and we'll call that P. So all regular polygons inscribed in a circle are going to have the same center. They also are going to both have a radius. So from P to A, we'd consider this a radius. Segment AP is a radius. We're going to also have another radius from B to P, and you can draw a radius from any corner of the pentagon to the center. So I could draw something from here, here, or here, and all of those are going to be congruent lengths. And that's just because we know from a circle that all radii are going to be congruent, all right? The new term that we're going to have here is if we've got this orange line, if you notice here I've drawn in, this right here is called the apothem. So I'm going to draw that up here. The apothem is a perpendicular segment that goes from the center to the edge of the regular polygon. You can consider that like the height of the triangle that I've drawn in here. All right, so apothem, that's a new word. You want to make sure you underline that or highlight that in your notes. The final thing we need to review is the concept of a central angle. Remember, a central angle is created from the center and two radii, which I've got drawn in here already, and a central angle is going to just be a portion of the total degrees of the circle. I'm going to go ahead and write down here the name of the central angle. So I could name that angle APB, and I'll mark that here in green. So APB is my central angle, and the easiest way to find the measure of a central angle is to take 360 divided by the number of sides. So that's a generic formula. You want to make sure you also add this to your notes. And so in this example, we would take 360 divided by 5 sides of the regular polygon. And that's going to tell us that the one central angle that I have drawn in here would be 72 degrees. So from APB, that angle is 72. And then from there, later we're going to show you how we can use this measure to use some trig in order to find some missing side lengths. So very key measurement there that you want to make sure you know how to find. And if you have any questions about that, please let me know.